Hello guys, my name is Lazaro and today we're going to be doing a LeetCode problem. This problem is called reverse nodes in K group. Given a linked list, reverse the nodes of a linked list K at a time and return its modified list. K is a positive integer and is less than or equal to the length of the linked list. So that already helps us out a little bit. It tells us not to worry about negative numbers. It also tells us not to worry if it's greater than the actual length of the linked list. If the number of nodes is not a multiple of k, then left out nodes in the end should remain as is. So, kind of how shown in this first example, when k is equal to 2, we can reverse this first group of 2 and the second group of 2. But once we get to 5, we don't have another group, we don't have another node that will make a pair. Therefore, we just leave 5 as is. And it's also the exact same thing in this one right here. When k is equal to 3, the first 3 nodes we could flip, but after that we don't have enough nodes to make a k group. So we just leave them as is. You may not alter the values in the list node, only nodes themselves may be changed. So we can't actually go into this node right here and change its value. We actually have to change the pointers and what the nodes point at next. So the first example, second example I already went over. So let's get right into the drawing and see if we can understand how to solve this. So I'm going to write down the first example. Perfect. So here we have it. Now the first thing I want to mention is that it would be extremely helpful if we actually have like a dummy variable or a dummy node in the beginning. And the reason we want this is because it's going to be helpful for certain test cases. Make it a little bit closer. There we go. So like I said, this would be helpful for certain test cases, and also when we're changing the pointers of all these nodes, we want to keep track of where we're looking at in case we have some global variable, for example, called answer. We can make answer point to this known node. And if we were to return answer, let's just say it points to right here. If we were to return answer, we'll be returning the correct list without any nodes being left behind. So for example, let's say answer was pointing to, instead of the known node, let's say it was pointing to 1. Where eventually 1 is going to be rearranged, right? We're eventually going to get 2, and then 2 points to 1, then 1 points to 4, 4 points to 3, and 3 points to 5. Here, if we were to return 1, or we were to return answer, we'll be returning this linked list, and we'll be excluding the 2. That doesn't really help, and that's going to be incorrect, obviously. So having this no pointer in the beginning is just handy and helps us out. So that's the first little trick that we want to use to solve this problem. The second trick is that we actually want to keep track of the indices of all these nodes. So starting right here, these are the indices. And let's say in the first example, k was equal to 2. And if you noticed, every time we get to an index, let's call it I, where the index I modulo k is equal to 0, we know that we have just entered the group, or a group. For example, right here, 0 modulo 2 is equal to 0. So we know that from starting at 0 and going down and visiting k nodes, that group we want to reverse. In this case, is for this one right here. then 1 modulo 2 does not equal 0. Therefore, we know that at this node, this is not this is not a starting node for a group of k. So let's say we move one more. Now we're at 2. 2 modulo 2 does equal 0. So we know that this node right here is a starting node for a group of k. And that is correct because it's this group right here. And then at this 5, it's also going to be valid, but of course we don't have another node. Therefore, we're not going to actually going to run this and compute it. So then that's the second trick to this problem, that we do care about the indices. It tells us which node is a starting node for a group of k. The second very important thing is that at all of these starting nodes, so it's 1 and 3, we can easily reverse it if we keep a gap of k. So what does a gap of k mean? Well, we're going to be looking at 1, correct? Or we're actually going to be starting at the known node right here. And if we were to keep a gap of 2, that means our second pointer will be looking at 2, or index 1. So why does this help us? Well, with this information, if we keep track of this gap, then we can easily reverse everything within it. For example, let's say if we take the next of our starting, which is 1. So let me do that in blue. So the next of our starting. And we also keep track of the next of our ending. Let's say ending here is our second pointer, which is pointing at 2. Then we can rearrange their pointers. We can say, oh, you know what, let me do this in a different color. There we go. There we go. Then we can rearrange their pointers and say, let's have 1 point to our second pointer right here. And this second pointer is going to kind of act as a previous variable. So let's say we have previous right here. It's currently looking at 3. Then on the next iteration, once we update this pointer, this arrow is now going to be looking at 2. And this arrow that was previously looking at 3 is now going to be changed, and it's now going to look at 1 because it's acting as a previous node variable. So now this is looking at 1. And for the current one we're looking at, which is 2, let's make that point to the previous. There we go. Now we can iterate one more time. Let's now change and let's actually look at 3 and let's have the previous be 2. But at this point, once we reach 3, we know that we want to stop. Because if we were to continue down this road, we would eventually get in a cycle where we would have 3.2, and then 2 is going to point to 1, then 1 is going to point to 3. And that's a cycle, and we don't want that for our linked list. So let's say this yellow one right here, let's call this A. This second yellow one, let's call that B. Once our current node, for example, is equal to B.next, we stop. There we go. Let's make that an if condition right there. So in the beginning, our current node was pointing at 1, and our previous was looking at 3. But then we keep on iterating. Our current node pointed at 2, previous pointed at 1, then our current node pointed at 3, and previous looked at 2. In this case, current node, which is 3, is equal to b.next, so that's when we stop. But there's one more thing that we have to do. We have to make a.next equal to b. So we want to change this pointer to now look at, well, this is getting pretty messy, to now look at 2. So if we were to write this out now, we have our null pointer pointing at 2, then 2 is pointing at 1, and then 1 is pointing at 3. And since we stopped at 3 with this if right here, we have 3 is pointing to 4, and then 4 is pointing to 5. And so far, as you can see, we have successfully reversed this K group. And we want to apply this logic every time we're at an index, every time we're at index I, where I modulo K equals 0. For example, let's say if once we visit 3, so we're at index 2 right here, we know that this is a start of a new K group. So if we were to apply, let me actually change my canvas size. So if we were to apply this logic that we were just looking at right now, we would have that A be pointing at 1, because remember A is always going to be before the start of the node that starts the K group. And then B will be looking at 4 right here. Previous will be looking at b.next, which in this case is 5. And current is going to be looking at 3. Now with this information, we can just start reversing some pointers. Current is going to point at previous. Then we can go for the next iteration. Cur is now 4. Previous is now 3. 4 is going to point to the previous. Cur is now 5. Previous is now 4. But we stop here because cur is equal to b.next. So with this taken into account, and we also have to remember to do a.next is going to be equal to b. So if we follow this logic of reversing and then this last crucial step, we will be getting something like this, where the beginning is the same as before, but now 1 is going to point at b, which is 4. 4 is now going to point at 3, and then 3 is going to point at 5. And as you can see, we are getting the correct answer. Now, since the index 5 is 4 and 4 modulo 2 is equal to 0, we will be doing this logic with 5, but we can just take care of this step by making sure that the gap, if the gap is not maintained, aka this gap of A and B, which is a gap of 2, so right here, where it's actually a gap of 3, but if you take this as 0 and then 1 and 2, it's a gap of 2. If we cannot maintain this gap, then we know we can just stop, and we can do something pretty simple to take care of that edge case. For example, we could just look at B. Uh, B is eventually going to get here, A is going to be here, and then B is going to be nowhere, and A is going to be at 4. And since B is nowhere, we know we can just fully stop and we would never even consider the 5 node because we can't maintain that gap. So now that we know the tricks to actually solve this question, the first trick being keeping this null node in the beginning to just help us out with a couple of edge cases and make sure that we're returning the correct linked list. The trick of keeping track of maintaining the gap. So when we're reversing, we know which nodes to change and when to stop reversing. And also the trick of looking at the indices to know when we started a new K group. So now let's put this all together in some code and see how this is going to work. So the first thing we want to do is let's just take care of a very simple case, and that is if K is less than or equal to 1, we know we don't want to do any operations to our linked list, so let's just return the head. Else, let's create a dummy, and this dummy is basically that null node we have in the beginning. Now let's try to maintain that gap of K, and we can do that by creating a start and end variable, where the start is going to be dummy and the end is going to be head. And now let's do a for loop to enforce that gap, to try to move end K places away from start. So for I in range of K minus 1, and we're doing minus 1 because remember we added a null node. So for I in range of K minus 1, if end, then end is going to be equal to end dot next. Else, we couldn't maintain this gap. Right from the beginning, we couldn't maintain this gap. So let's just have n equal to none, and let's break. Now let's keep track of the indices with this POS, or standing for position variable. Set that equal to 0. Now while end, so as you can see right here, we cannot enforce the gap. Set end to none. Therefore, this while loop, where we're going to be doing the majority of our logic, it would never run. So in here, if the position modulo k is equal to 0, then we're going to want to do the reversing. First, let's create a temporary variable for end. Let's set end equal to its next variable, or the next node. And now let's reverse everything from where we're currently at in start all the way to temp, which is why we create that temp variable right here. So now let's build out this reverse function. So we're going to want to get the next node at the end. Remember, this is extremely useful right here. B, think of B as our end. And we're going to want to get this 5 because it's useful, because that's where we want our current node to point at. And let's set previous equal to next end next. Because remember, initially, that's what previous is. Previous is equal to the next of end, which is B. Now our current node is equal to start.next, because remember that start is one behind, as we have right here. A is start, but the current node that we want to look at is 3. So while node does not equal end underscore next, let's update its pointers. Let's also update the previous, make it equal to node, and let's increment node. So let's increment the current one we're on. Let's set previous to this one we're currently looking at, and let's change the pointer of the one we're currently looking at to be equal to previous. I said that in the wrong order, but you get the gist. And finally, that crucial step is to set start.next equal to end. Perfect. So now that we have the reverse function built out, we can go back to our while loop. Else, if we're at a position that is not the start of a k group, let's just increment end. We want to always increment end because we want to maintain that gap. We also want to always be incrementing position and as well as start. Because if we increment end, we have to increment start. And this is really all the logic we need. From here we can just return dummy.next. And remember, we're doing dummy.next because the first node is just a null node that we use to help us out. So let's run the code and make sure I didn't make any errors. Alright, looks like I did make one error. Let's see if we can find it. Alright, and it's right here. End dot on end Alright, and it's right here. End underscore next should be equal to end dot next. So let's run this one more time. And it's accepted. Let's submit. This is also accepted. Awesome. So hopefully you guys were able to understand this. Now this is a LeetCode hard and it's pretty confusing, but hopefully the drawings really helped out and you guys were able to take away the three main things about this problem, which is the indices right here, the indices, the importance of maintaining that gap of k, and the logic of reversing, and of course this null node, its purpose. Other than that, I hope you guys enjoyed, and if you did, please leave a like and consider subscribing. Thank you very much.